Volcanoes. On August 27, 1883, the uninhabited island of Krakatoa exploded. Krakatoa is a volcanic island located between the islands in Indonesia. As a result of this eruption, more than 36,000 people were killed and 165 villages were destroyed. Of those 36,000, about 1,000 people were killed by hot ash and scalding volcanic gases. The remaining thousands were killed by water. Water, you ask? Well, the eruption sent tsunamis outward in all directions, sending waves as high as 40 meters onto land, destroying villages along the shorelines. It has been said that the sound of the eruption was heard in Australia, Philippines, and Sri Lanka, which are all more than 4,700 kilometers away. Krakatoa is located along a convergent boundary where the Australian plate is moving north, colliding with the Asian plate. A subduction zone has formed, causing this region to have many active volcanoes and numerous earthquakes. A volcano is a weak spot in the crust where molten material, or magma, comes to the surface. Magma is a molten mixture of rock-forming substances, gases, and water from the mantle, and when this magma reaches surface, it is called lava. After lava has cooled, it forms solid rock, and this lava released during volcanic activity builds up on Earth's surface over time. On Earth, there are about 600 active volcanoes on land, and many more lie beneath the ocean, where some have never even been observed or even mapped. Now, scientists have learned that the movement of Earth's tectonic plates cause the formation of volcanoes and eruptions that result. Volcanoes can form along convergent plate boundaries where one plate subducts into the mantle. During subduction, magma forms when one plate sinks beneath the other. Magma is less dense than the surrounding mantle and will rise through cracks in the crust, forming volcanoes. Lava can also erupt along divergent plate boundaries where two plates spread apart, and as these plates separate, magma can rise through vents or opening in Earth's crust that form between them. This process commonly occurs at mid-ocean ridges and forms new oceanic crust. And then not all volcanoes form on or near plate boundaries. Some volcanoes, like those in the Hawaiian Islands, are far from plate boundaries. Volcanoes that are not associated with plate boundaries are called hotspots, and we're going to discuss that in just a little bit. Now this figure shows the location of some of Earth's major volcanoes. Notice how the volcanoes occur in belts that extend across continents and oceans. One major volcanic belt is the Ring of Fire, formed by many volcanoes that rim the Pacific Ocean. You can see the volcanoes are mostly along convergent plate boundaries where plates collide, and they're also located along divergent plate boundaries where plates separate. Sometimes the result of volcanoes can create a string of islands called an island arc. The curve of an island arc echoes the curve of its deep ocean trench. Major island arcs include Japan, New Zealand, Indonesia, the Philippines, the Aleutian Islands, and the Caribbean Islands. The Hawaiian Islands are formed differently, and geologists hypothesize that hotspots originate above rising convection currents from deep within Earth's mantle. They use the word plume to describe these rising currents of hot mantle material. When plates spread apart, it forces magma to the surface and creates new crust. As the tectonic plate continues to move over the plume, the first volcano will become dormant or inactive, and then over time, a new volcano forms as the plates move. The oldest volcano will be the furthest away from the hotspot, and the youngest volcano will be directly above the hotspot. If you were to look at the map of Hawaiian Islands, here, the furthest to the upper left-hand corner in this image is Kauai, and this is now done. There's no active volcanoes here. And the largest one down in the right is the island of Hawaii, which still has an active volcano to this day at Kilauea National Park. A volcano is more than a large cone-shaped mountain. Inside the volcano is actually a system of passageways through which magma moves. All volcanoes have a pocket of magma beneath the surface and one or more cracks through which the magma forces its way out. Beneath the volcano, magma collects in a pocket called a magma chamber, and from this chamber, the magma moves upward through a pipe, which is a long tube in the ground that connects the magma chamber to Earth's surface. Molten rock and gas leave the volcano through openings called vents, and often there's one central vent at the top of the volcano. However, many volcanoes have other vents that open on the volcano sides. As lava pours out of the vents, this is called a lava flow, and many times at the top of the central vent, a crater or a bowl-shaped area forms. There is a presence of dissolved gases in magma, and these dissolved gases contribute to how explosive a volcano can be. This is very similar to what happens when you shake a can of soda and open it. The carbon dioxide in soda is dissolved inside that soda, so when you open the tab and release that pressure, the trapped bubbles increase in size rapidly and escape as the soda erupts from the can. Dissolved gases in magma include water vapor, small amounts of carbon dioxide, and sulfur dioxide. So as magma moves towards the surface, the pressure from all the weight of that rock is also decreasing. And as the pressure decreases, the ability of gases to stay dissolved in the magma also decrease, and eventually the gases can no longer remain dissolved and bubbles begin to form. So when this volcano erupts, the force of the expanding gases pushes magma from the magma chamber through the pipe, and then this magma can either flow or explode out of the vent. Geologists have classified volcanic eruptions as either quiet or explosive. A volcano erupts quietly if the magma flows easily and the gases in the magma bubble out gently. Lava with low viscosity that is quiet from the vent, it will flow quietly from the vent, and it can flow for many kilometers. Quiet eruptions can produce both pahoehoe and aa, which are different types of cooled lava rock. Now, a volcano erupts explosively if a magma is high in silica, causing the magma to have high viscosity, making it thick and sticky. This high viscosity magma does not flow out of the crater. It bubbles up in the pipe and it kind of plugs it up like a cork in a bottle. So when those dissolved gases, including this water vapor, cannot escape, this thick magma and the trapped gases build up pressure until it just explodes out of the top. The erupting gases push magma out of the volcano with such incredible force, like what happened in the Mount St. Helens explosion. Now, explosive eruptions break lava into fragments, and these turn into quickly hardened pieces of rock of different sizes. The smallest pieces are volcanic ash, and the largest pieces are called bombs, and these bombs may range from the size of a baseball to the size of a car. And in between are pieces that are smaller called cinders. Now, a pyroclastic flow occurs when an explosive eruption hurls out the mixture of hot gases, ash, cinders, and bombs. Geologists often use the terms active, dormant, or extinct to describe the volcano stage of activity. Active volcanoes are live volcanoes and are either erupting currently or show signs that they may erupt in the near future. Dormant volcanoes are kind of like sleeping volcanoes, and scientists expect dormant volcanoes to awaken sometime in the future and eventually become active. And then there's an extinct or a dead volcano, which is unlikely to erupt again. All right, it is time to show what you know.